Hi everyone, the topic we are going to see today is page replacement algorithms. What is the need for page replacement? When multiple users are using the system at the same time, there might not be enough space for saving all the data in the physical memory. In that situation, the data which are stored in the physical memory, few may be backed up in the secondary storage, and the space consumed by that data can be allocated for the necessary user. This is known as page replacement. For that, we have to select the victim frame. That is nothing but which data can be moved to the backing storage, and that space allocated for that victim will be reallocated for next data. This is the process of victim selection. For victim selection, there are three different algorithms used. First one is first in first out algorithm. Next one is optimal page replacement algorithm. Third one is least recently used page replacement algorithm. In today's session, we are going to see about the implementation of all those three algorithms. In first in first out page replacement algorithm, the input given is a sequence of reference string. In that, let's consider the above given as the sequence of reference string, and the frame size will be given. Today the frame size we are considering is 3. So in this, the process of FIFO is first in first out, right? Whatever the data which arrives first will be allocated for the frame. In this, 7 is the first string which arrives, so 7 will be allocated for the frame. Next, 0 arrives, so 0 is allocated to frame 2. Then 1 arrives, 1 is allocated to frame 3. Then when the 2 arrives, all the 3 frames are filled with 7, 0 and 1. So now we have to replace a frame and add the value of 2 on that frame location. So here we have to select the victim frame. In this, since this is first in first out, the victim frame selection is based on first arrival string. So which string arrives first will be selected as victim, and it will be freed and it will be allocated for new arriving string. In this 701, 7 is the first arrival string. So 7 will be selected as a victim and it will be freed, and the new arrival string 2 is allocated in the place of 7. So now the value of 2 is placed in the frame 1. Then next, the string 0 arrives. While checking this frame, the frame contains 2, 0 and 1. Since the value of 0 is already available in the frame, we won't disturb the frame or we won't modify the data. We will just skip that and go for next arrival string. The next arrival string is 3. So in this, when we see the frame, 2, 0 and 1 are the data available. So 3 is a new arrived data. In this, we have to select the victim. For selecting the victim, we will be considering the first arrived data. In 2, 0 and 1, 0 is the value which arrived first. So in the place of 0, the value of 3 will be replaced. Then next string arrived is 0, and this 0 is not available in the frame, so we have to select the victim. In considering 2, 3 and 1, 1 is the first arrived string. So in the place of 1, 0 is replaced. The next arrival string is 4. In this 2, 3 and 0 which are available in the frame, the value of 2 is the first arrived string. So in the place of 2, 4 is replaced. Now the next arrival string is 2. The available data in the frames are 4, 3 and 0. In comparing these three values, the value of 3 is the first arrived data. So we are replacing the value of 2 in the place of 3. Then the value of 3 new string arrived, but the available data are 4, 2 and 0. Comparing these three, 0 is the first arrived data. So we are replacing the value of 3 in the position of 0. Then the next data arrived is 0. Comparing 4, 2 and 3, 4 is the first arrived data. So we are replacing 4 with 0. Next, the arrival string is 3. While checking the frame, the 3 is already available in the frame. So we are not doing any modification in that. We are just keeping the value of 3. Then the next value arrived is 2. When we comparing the frames, 0, 2 and 3 are the values available. Since 2 is already available in the frame, we are skipping this value and we are moving to the next string. The next string arrived is 1. Since the values 0, 2 and 3 are available in the frame, we have to find the victim frame and replace the value with 1. In 0, 2 and 3, the first arrived string is 2. So we are replacing the value of 2 with the value of 1. Now the available data in the frame are 0, 1 and 3. Next arrival string is 2. So we have to find the victim frame. For this, 0, 1 and 3. 3 is the first arrived data. So we are freeing the value of 3 and allocating that space to 2. Next, the arrival string is 0. Since 0 is already available in the frame, we are moving to next string and considering 1 is also available in the frame. So we are moving to next arrival string. Next arrival string is 7. In this, while checking the frames, 0, 1 and 2 are available data. In that, comparatively 0 is the first arrived string. So we are replacing the value of 7 in the place of 0. Now the current data is 7, 1 and 2. The next arrival string is 0. In this, 1 is the first arrived string. So we are replacing the value of 1 with 0. Then the next arrival string is 1. In 7, 0, 2, 2 is the first arrived data. So we are replacing the value of 2 with 1. Then in this, the page fault, how many times we are accessing the frame and changing the values is considered as page fault. Okay. In this, the total number of page fault occurrence is 15. While we consider 7, 0, 1, 2, then 0 is not changed. So we will lift it out. 3, 0, 4, 2, 3, 0. And next 3, 2 is not allocated. Since it is not modified, it is also left over. Then 1, 2 is considered. Again 0, 1 is omitted and 7, 0, 1 is considered. So total frames are 15. So 15 is the page fault occurrence for this string sequence while allocating in FIFO page replacement algorithm. Let's see the other two techniques of page replacement algorithm.